All right, so again, we're on page 27, and we're going to talk about applications to marginality, which is just the fancy phrase for business type applications. And let's just refresh our memory for what we did at the end of last class. We did do one of these problems. We were trying to sell penicillin. Every time we sold one, we made $200. That was our revenue for each item. But of course, we had to pay some production costs, and that was this complicated formula with the Q, where Q is the quantity, number of units of penicillin that we sell. And we also had a maximum of 30,000 units per week that we could sell. And so we did some work and ultimately ended up finding the number of units of penicillin. It was 20,000 that maximized the profit. And that's the goal for today, is to maximize the profit. So let's go down to number 3, and we'll go to Ernie. Can you read 3? Okay, so we are defining new phrases right here. If you see marginal, marginal is a business word. What does it mean in calculus speak? It means derivative, okay? So in an economics or business class, if you hear the word marginal, you think derivative. That's all that it is. So pi prime is the marginal profit, r prime is the marginal revenue, and c prime is marginal cost. And I should also say it's been many years since I have taken an economics class. And so if you have been in one more recently and you have stuff to contribute, please jump in. So let's take a look at number 4. We'll go to Richard. Okay, so we know that profit is revenue minus cost. If I take a derivative, I just get r prime minus c prime. Right? Derivatives are nice when there's a subtraction involved. Okay, let's keep going. We're up to Abby. What's the magic number for a critical point? 0. So we're looking for places where pi prime is equal to 0. But pi prime is this thing that I've written here in purple. If I want that thing, this thing right here, to be 0, what must be true about r prime and c prime? How do I make this thing 0? Yeah, what must be true about r prime and c prime if this is supposed to be 0? It better be equal, right? If I want that to equal 0, then r prime and c prime had better be exactly the same number. So that's what's written down here. To maximize profit, we're looking at endpoints, of course, and critical points. And the critical points happen where r prime equals c prime, because that's where the derivative of profit is 0. And so if you've taken an economics class, you might have seen this kind of phrase before. You're looking for marginal revenue to equal marginal cost. It's exactly what we said up here. We want marginal revenue, the r prime, to equal marginal cost, the c prime. So let's go to the next page. Take a look at number 5. Andy, are you ready? Andy, can you read 5? Okay, so there's the function. It's the same one we played with last time. We have used this idea of producing one more. We've thought about the derivative as of telling you what the next one will be. We did some example where we were operating like a frozen banana stand, and you guys had some information about the derivative, and you said, oh, if the derivative is $2, then what we're saying is that the next banana you sell is going to bring in roughly $2 more, right? And so we've seen this before, but let's actually see it with a specific function. So there's our cost function right there. Again, Q is the quantity, number of units of penicillin that we sell. So people with calculators, can you help us find these things? I want the total cost of producing 19,999 items, the total cost of producing 20,000, and the total cost of producing 20,001. So these numbers should all be getting what? It's a total cost function. What should be happening to these numbers? Chris? They better be getting bigger, right? It's a total cost, but they don't necessarily have to get bigger by the same amount every time because the costs can change depending on how many things you're selling. Anybody have a number for us? Is that exact or was there a, okay, thank you. All right, anybody have, yeah, Tiffany? What, did I have the right digits? 800, okay, thank you. All right, other numbers is the next one. Okay, so, and that's exact. Okay, and then the 20,001. I'm just gonna go ahead and do it in my head. Is that right? Somebody type that in for us. Thank you. Okay, I didn't cheat. Certainly didn't know the numbers before I got to class today. Okay, so what's going on here? How much did it cost us to produce the 20,000th unit? These are total cost functions. So what do we do with these numbers? We subtract them. And when you subtract them, what do you get for producing the 20,000th unit? It's very close to 200. Is it a little more or a little less than 200? That difference. It's a little less than 200. So it's $199 and what, like 997? Is that right? Okay, so that's what it costs us to produce the 20,000th unit. When you subtract the next two, you'll find the cost of producing the 20,001st unit. Is this one a little more or a little less than 200? That's just a tiny bit more than 200 by fractions of pennies, okay? Now, it was easy enough to find those numbers, but to be honest, even with this wonderful calculator we have, it was still a little bit of a pain to type all that in. Let's see what the derivative does for us. So those are the right answers. Those are the exact answers. We're going to estimate those things by finding a derivative. Are we okay? Is there just rampant disgust because of the quiz? How are we doing? But look, you got tomorrow and Friday off, so like the quiz will just be a distant memory soon enough. All right, C prime of Q. Let's take a derivative here. Okay, so there's our derivative, easy enough. And what I'd like to do is plug 20,000 for Q in this thing. So I want C prime of 20,000. It's 200. And that was darn close to the actual cost of producing the 20,000th unit of penicillin. What's that? Pretty darn close. So it wasn't perfect because the derivative changed a little bit between 20,000 and 20,001. It changes a tiny bit all the time. Yeah, so again, marginal cost is supposed to represent the cost of producing one more item. So the derivative of cost is how much it will cost you to produce one more item. Okay, and then there's this question here at the bottom. Do you see why the maximum profit occurred at a production level of 20,000 units? So this is now 2 days ago. So let's remind ourselves again that we did this in a table over here in blue. We had 0 and 30,000 were the end points. Can't produce less than 0, and 30,000 was the capacity of our production. And 20,000 was called the what? That was the critical number. And so we made a table, and we actually didn't fill in the table. We ran out of time yesterday. But what we would have seen was that that number right there was the highest number in the profit function. That represents the maximum profit. And so why is it happening that, is there something in this 200 that we should see that tells us that producing 20,000 is exactly how many we should produce? Well, suppose that you produce exactly 20,000 units. How much did that last one cost you to produce? How much did it cost us to produce that 20,000th one? Was it just over or just under 200? Just under 200, right? It cost us $199.997 to produce the 20,000. How much revenue did we get for any level of production? We can go back and look at the problem on the previous page. Every time we sold one of these penicillin units, we made 200 bucks. So was it in our best interest to produce the 20,000th one and sell it? You bet. We just made $0.003, like 3/10 of a cent, because that number is less than the $200 revenue that comes from it, right? So we should absolutely produce it. But when we get to decide about whether or not to produce another one, what happens to our profit when we sell the next one? It goes down, because the cost of producing the 20,000 first is just over the revenue we get from selling the thing. So we should stop there, because that's the last one, which is less than the $200. And in fact, if we come up here and write the revenue function, if the revenue is $200 per, then what's the revenue, the total revenue function? 200 Q, right? That's the total revenue you get for selling Q of these things. And it's real easy, almost too easy to bother with, but what's the derivative of the revenue function? It's 200. And what's happening at this one spot about the marginal revenue and the marginal cost? They're equal to each other. And that was the conclusion we came up with on the last page, and it's confirmed here. If you want to maximize your profit, you sell, sell, sell until the marginal cost is exactly the same as the marginal revenue. Because up until that point, presumably, the costs are less. And so you sell more. Keep selling until they become equal, because once you get past where they're equal, all of a sudden the cost of producing the next one is more than the revenue that comes in from it. All right. Yeah, and we're going to look at some graphs. So I think, Ernie, you've had some economics classes recently, right? This is yeah, it's a great connection that you're making. So we're going to look at some slopes in just a few minutes. Okay, so let's go to number 6 to conclude this part, Josiah. Okay, thank you. We'll go to Todd for 7. Okay, so we're going to draw a quick little sketch here. We've got quantity here on the bottom axis. Cost, I'm going to write the word, I'm going to put TOT, total cost is what we're after. And assuming that the cost is linear, meaning every time you make another unit of penicillin, it costs you exactly the same thing, we can draw a graph. Is this line going to be horizontal, uphill, or downhill? It's a total cost function. Downhill? It's total cost. What was happening to the numbers here in blue? It was increasing, right? I mean, it's got to get bigger because it's a total cost function. Even if the cost per decreases, the cost for each one, the total cost has to go up. So I have a couple of choices for lines that I could draw that are increasing. I could draw this kind of a line, this kind of a line that goes through the origin, and this kind of a line. Only one of them really makes sense. Is it the origin? Yeah. Yeah, because of the fixed costs. That's the one that makes sense, right? Even if you don't make anything, you still have to pay like property tax and you still have to pay like the mortgage on the building, and there are fixed costs associated with our business. So the top one is the right one, and we can get rid of the other ones here. These ones don't make sense. So there's a linear version of things, but maybe slightly more realistic would be an S-shaped thing. So let me see if I can draw a curve here that is a little more believable, a little more realistic. Okay, so you've already convinced me that no matter what I draw, I better start somewhere up on the y-axis. There's fixed costs associated even if I make 0 items. Okay, so if you have this whole big business running and you make 1 item, is that good or bad? It's probably pretty bad if you've set up this whole infrastructure and you got everything working and the assembly line is ready and you pop out 1 unit of penicillin. So the very first one is probably going to be quite prohibitively expensive, but as you make more and more, maybe it gets less and less expensive per unit that you make. So the only difference between increasing functions is going to be concavity. So which one do you think we're going to draw if we're making it so that they cost less and less each item that we make? It's concave down, right? Because the first one will cost quite a bit, but then maybe the second one won't cost as much, and the third one is a little bit less expensive. So we get something like this, and I think the phrase that economists use is economies of scale. What am I doing? Economies of scale. But it doesn't just continue to become linear. I mean, I suppose if everything just became, it costs $5 each, it would just become linear. But it doesn't do that because we run into the problem of maxing out the abilities of our workers or the abilities of our plant. And if you have to buy another building because you've used all the resources in the first, or if you have to pay overtime or hire more employees, then all of a sudden things become more and more expensive. And so I guess I would say that out here is exhausting our capacity, something like that. And then maybe if you've got another building, it can start to level off again at some later point, but there's maybe a more realistic thing than the straight line. Oh, good. I used the phrases that are down right below. Probably should have looked at that. So for the S-shaped version, economies of scale, and at the high production levels, an exhaustion of capacity. All right? Okay. Number 8, instead of looking at costs, we're going to look at total revenue. So again, we'll have a linear version and then maybe a more realistic one. And for both, quantity is on the horizontal and total revenue is on the vertical. Does that represent a point or? For me, I've got an interval. You're right. It could just be like a point where really it would be like a jump. I mean, it's a simplification that we're making here because you can't sell 1.3 units of penicillin. So really, this should just be a bunch of dots, and we're trying to connect them so we can do calculus on them. But you're right. The moment we buy the other building, this point is here, and the very next point is this massive jump up there, and then maybe it's smooth, and then if you have to hire more workers, then again at that moment you have a jump. For me, I'm picturing just all at one time we have to buy a new building and we got to get more machinery and more workers hired. So for me, it's a whole it's an interval, but I think you're right. I was asking Yeah, I mean that's the point of inflection, the one where things start to go sour for us. Yeah, I think that's a good observation. Okay, so down here we're looking at total revenue. I'm going to draw 3 lines again. If it's a linear thing, one is below, one is supposed to go through the origin, and one is up here. Which one makes the most sense for the total revenue? Why the origin one? Yeah, if you make 0 things, your revenue is 0. This one, there's no fixed revenue coming in. That would be nice if there was, but this guy here in the middle is the one that makes sense. Super. But in reality, if you sell more and more and more of something, um, there becomes a lot of supply out there. And unless the demand is there to meet that supply, then what are the people selling your objects going to have to do in order to continue to sell them? They're going to have to reduce the price, right? If there's so many things out there of a certain kind, prices are going to come down. The supply is real high. So I'm going to draw my kind of straight line thing here. And then again, it's all about concavity. It has to continue to increase. Will it increase concave up or concave down if we've sort of glutted the market? It's going to be concave down. So there's our freeze. There's so many of our objects out there, we just can't get the same revenue. We can't keep charging 200 each because there's so many of them out there. People are only willing to spend 150 and then 120 and then 80. Okay, so that is that. Let's go to the next page. And this is a little bit of what Ernie was after. We're going to look at some graphs. So I've given you some screenshots here. The Y1 function, what is that in our example? Is that the revenue, profit, or cost? I think that was the cost function. Okay, so there's the cost function. 200x is the revenue function. So you got the scales there, and then let's go ahead and label which one is revenue and which one is cost. Okay, so revenue is the straight line, and then the cost is the curvy thing. And let's go to number 10. Sam? Okay, so break even. I don't think we've had that phrase in this class, but I bet a lot of you know what it is. What does it mean? Profit should be 0, right? You're not making money, you're not losing money. You want the profit to be 0. Looking at the revenue and the cost function, can you identify any points where the profit is definitely 0? It's where these things cross each other. Because if the revenue exactly matches the cost, then your profit is 0. So the break-even points are here and here. I'll underline, in purple right there. So those are the break-even points, easy enough to grab. And they're also worth knowing because suppose that you sell less than this number, whatever it is. What's my scale here? 40,000, 10,000. So let's say that's about 5,000. So if you sell exactly 5,000 units of penicillin, what's true about the profit? 0. What if you sell less than 5,000? Which curve is above in this space out here? Yeah, if you're looking in here, the cost curve is above the revenue. So what's true about the profit in there? Yeah, this is a negative profit space. So maybe we can identify that. So here we go. We're in the red. Is that the right phrase? Yeah, okay, so we're losing money. Losing money in there. What if you're between? Which curve is above? Is the revenue curve. So the profit for that entire space is positive. So that one, I say we're in the black, but we'll call it green for money. So anything here is making money. I guess that goes until about there. And then to the right, again, we're losing money. So I think we get some good graphical information just by having a picture in front of us. We could say to our boss, okay, bozo, don't sell anything less than 5,000 and not anything more than whatever that number is, 30,000, and we'll be okay. So that's good. But maybe more important than just saying, all right, let's be in the black, which is green in my picture, more important than just saying, let's make money. What else do we want to happen besides just making money? We want to maximize the amount of money that we make. Now, if I draw, there's something I could draw here. Suppose that we sell this number right here. That's 10,000 units of penicillin. Can you figure out something you can draw in this picture graphically that will represent the profit at selling 10,000 units? Yeah, so we're going to draw a line Is it horizontal or vertical? Vertical. If we go straight up there to the 10,000, the 2 points that are 10,000, and you connect them with a vertical line, then the length of that vertical line represents profit, right? Because that's subtracting the revenue, which is the top one, minus the cost, the bottom one. And so for me, I imagine kind of sweeping out a bunch of these vertical lines. And you can see the vertical lines are pretty small near the break-even points. That makes sense. And the biggest ones are someplace in between. They don't have to be perfectly in the middle, but do you believe that the max profit is the one that has the biggest space vertically between those two curves? Okay. So here's another graphical thing. We've already decided that the max profit occurs when the marginal revenue and the marginal cost have a very special relationship. It's when they're equal. That's what we figured out before. We want the marginal revenue to exactly equal the marginal cost, and that's going to be a potential place where the max profit occurs. So thinking about graphs and calculus things, marginal cost is the derivative of that curve. What does it represent graphically? Slope of a tangent line. So let me erase our, that's too much erasing. So let's erase these little blue lines for a second and instead think about tangent lines. So I'm going to draw in blue a tangent line at this point, and in red I'll draw a tangent line at this point, which is actually just the line itself. Which one is steeper at that point? Maybe that tangent line at the bottom didn't look so good. Let's try that again. So at that point right there, maybe that's a little better. Which one is steeper? The revenue one, which means that the revenue you get from producing one more is more than the cost that you pay for producing that one more. So should you produce another one? Yes, you should. And if we keep going, and maybe we go a little bit too far, I'll go out to here. So the revenue tangent lines are all the same. They're all slope of 200. And then my blue tangent line now is here. Maybe it's something like that. Which one is steeper at that point is the cost. So the revenue you got from producing that one is smaller than the cost that you paid for producing it. So we shouldn't have gotten that far. What are we looking for? What's the magical spot in between? Is when they're parallel, right? We want those slopes to be exactly the same. So you want the tangent lines to be parallel to each other. That gives you the marginal revenue equal to the marginal cost. So it's hard to know because this is a tiny little graph here, but roughly looking for a place in here-ish where the slope of that one is exactly the same as the slope of that one. That's our margin, that's our maximum profit point. Okay, so far so good. Let's graph something here. So you can do this on your calculator or you can just watch. I didn't mean to pull up GeoGebra, so let's scratch that. So what I'm interested in now is graphing not the total revenue and cost functions, which we have here, but rather the marginal revenue and cost functions. So the marginal cost function is the derivative of this guy, which we've already said a few times today. Is 80 plus 0.006x. Do I have that right? And then what's the marginal revenue, the derivative of this? 200. I'm going to go ahead and use the same window. No, I'm not. That would be silly. I'm going to use 0 to 40,000, same as we had over there. But for the y values, we'll go 0 up to, I don't know, 400. Let's see how this looks. Okay, the first one, the diagonal one, is the marginal, which one? Is the marginal cost. And you can see what's happening to the marginal cost as you go to the right. It's getting bigger. The cost of producing more is costing you more. Each one that you make is costing a little more than the one you made before. But the revenue is that horizontal line. How come? Because the revenue was fixed at 200 every time you sell one. Doesn't matter how many you sell. And where's the max profit point looking at the marginal revenue and the marginal cost? It's where they're equal to each other. If you are someplace out here, the revenue, the marginal revenue is bigger than the marginal cost, so you're making money there. If you're out here, the marginal cost is more than the marginal revenue. But if you're right there, you're at the magic spot where they're equal, where the tangent lines were parallel in our picture behind here. And so if I intersect these guys, so we choose number 5, Enter, enter, enter. The point was already selected, so let's try it again. I'm going to move the cursor just so that we can build some more suspense. So enter, 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 and the answer is at 20,000, and the marginal revenue and marginal costs are 200, both of them at that point. Okay, so that is good. Let's jump down to number 13. So 13 gives you a revenue function and a cost function, and I'm looking for the maximum profit and then this sort of opinion question, is it a good business? In 14, same kind of thing, but slightly different functions. And so what I'd like you guys to do in your groups is look at those two. But before we do, I think we'll take our quick look at the calendar. So lots of action today. We had our 7th quiz. You have the 6th project hopefully in the folders for me. And the 7th project is assigned right now. It's on the table. So everybody grab one if you haven't grabbed one yet. So again, there are no classes tomorrow or Friday because of Thanksgiving. I'm also pretty sure there are no classes tonight. Wednesday evening classes are canceled tonight. And then we come back on Monday and we're going to spend not 1 but 2 days on related rates. And then we do this thing called L'Hopital's rule. And that's the last new section that's going to be on our test number 3. So after today, we got 3 days of new material, although it's really only 2 topics until test number 3. So the review day for test 3 is the 3rd, and test 3 is going to happen December the 5th. What day of the week is that? In a second. Or is that Wednesday? Yeah. Okay, so a week from this coming Wednesday is our 3rd test. Any questions on any of that? Okay, and then one piece of good news, this 7th project, well, it's quite challenging, so that's not the good news, but the good news is that it's the last like real math project of the semester. There is an 8th project, but it's just going to be one where you reflect on what we have done together this semester. So this is the last math project, so, per se. I dropped 1 project. Yeah. Okay. All right. So we have like 7 minutes or so. See how far you can get. Trying to maximize the profit. There aren't really any endpoints. I guess 0 is an endpoint, but there's no maximum capacity for these guys. So just take some derivatives, set them equal to each other, and see if you can find the max profit.